Hi, welcome back to section 11.1, solving system by substitution. In this video, we're going to cover special cases. So let's take a look at the first system we have here. So the first equation of this system is negative 3x plus 6y equals 230. The second equation is 2x minus 4y equals negative 20. So when we're solving for substitution, where we have both equations with x and y on the left side of the equal sign, so we would have to pick one equation, and I usually recommend that you would pick the one equation with the lowest coefficient for whether it's x or for y. So here I circle in red the 2x because this is the lowest coefficient between 3, 6, and 4. So we're going to use the second equation. And when we're isolating, we want to make sure that we have whole numbers. Now, in the event if you do have fraction, you're just going to have to make sure to work with fraction in terms of multiplying, adding, subtracting with fraction. So as I said before, we're going to focus on the second equation. So what I'm going to do is I'm going to cancel out the negative 4y. Now the reason I want to cancel out is because I want to get the x by itself. And the reason I want to get the x by itself is because the x has the smallest coefficient. And again, coefficient is the number that's in front of the variable. So like I said, I'm going to cancel out the negative 4y by adding 4y to both sides. So when I do that, I'm going to have on the left side of the equal sign just 2x now, and then on the right side it will be 4y minus 20. Now when I added, I put the variable first in front of the number. Now if I did this with x, I'm still going to put the x in front of the number. So here I'm going to put 4y and then minus 20. After that, I'm going to continue getting the x by itself. What I'm going to do is I'm going to divide both sides by the coefficient. In this case, I'm going to divide both sides by 2. So I'm dividing on the left side by 2. Here on the right side of the equal sign, I'm going to divide 4y by 2 and divide negative 20 or minus 20 by 2. When I do that, I'm going to get x equals 2y minus 10. So now I have x by itself. So again, we convert the second equation into an equation where the x variable is by itself. So since this is from the second equation, what we're going to do is we're going to plug it into the first equation. So what I did, I moved the first equation to the side. And as I stated before, we're going to plug the second equation where x is by itself. We're going to plug it into the first equation in place of x. So I plugged the second equation, x equals 2y minus 10. So I plugged in 2y minus 10 into x, or I substituted x with 2y minus 10. I put it in parentheses because if you look at the first equation, negative 3 and the x, they're multiplying to each other. So when I replace x with 2y minus 10, I am essentially multiplying with the negative 3, which is why I have it in parentheses. So I'm just going to do like in the previous videos, previous example, I'm going to distribute the negative 3 to the 2y and the minus 10. So when I did that, I get negative 6y plus 30. So after distributing with the negative 3, I'm going to combine the 6y's, the negative 6y and the positive 6y. So that got me 0y. Now normally when something cancels out, you don't really keep it in terms of solving an equation. But here, I'm going to keep the 0y, and I'm going to use that to help explain the special cases. So I combine the y's together and they cancel out. So I'll put 0 for 0y. Now, I'm going to cancel out the 30 from the left side of the equal sign. So I'm going to subtract 30 on both sides. So when I do that, on my left side, I'm just going to have 0y, and on the right side of the equal sign, I'm going to have 0. So 30 minus 30, that cancels out. Now the system that we just saw, we end up with 0y equals 0. Now the reason I kept the 0 for the y was to indicate the special cases. Now when you have 0y equals 0, this is one of the special cases where we would finalize with infinite solutions. So while you work this system out using the substitution method, if you end up with 0y equal to 0, after you double check and your work was correct, then you can just stop and finalize with infinite solution. Now if you end up with the other case for x, if you have 0x equals 0, then you can also stop, double check your work. If your work is correct, then you would finalize with infinite solution. Now this is the one case for infinite solution. We have another special case. So if you were doing substitution method and you end up with this particular case, where you either have 0x equals to a number, whether it's positive or negative, you would say no solution. If you end up with 0y equals to a positive or negative number, it would be the same thing. You would just finalize with no solution. Now, again, you want to be careful. If you do end up with a 0y, a 0x, make sure you double check your work was correct. If it is, continue. If you end up with 0y equals 0 or 0x equals 0, then you can finalize with infinite solution. If you end up with 0x equals to a positive or negative number, or if you end up with 0y equals to whether it's a positive or negative number, then you can finalize with no solution, okay? You don't have to have both cases to show me that 0y equals 0 and 0x equals 0. If you see that and your work was correct, then you can just finalize. I'm just showing whether if you get a 0 for y or 0 for x. If it equals to 0 at the end, you can finalize with infinite solution. Same thing for the no solution. If you end up with a 0x or a 0y and it equals to whether it's a positive or negative number, then you would finalize with no solution. So make sure you take note of these two special cases.